Hey Chem Kids, Campbell here, and welcome back to Bond, Chemical Bond. Today we're going to talk about Lewis structures for ionic compounds. Well, first let's do a little review. Remember, bonds are the force that holds atoms together. And today we're going to talk about ionic bonds and Lewis structures. Remember, ionic bonds are the transfer of electrons between atoms. And covalent bonds is about sharing. But we're going to talk about covalent bonds and Lewis structures in the next video. So another little bit of review. Remember that the valence electrons are the electrons that are involved in bonds. And the valence electrons are those ones in the outermost energy level. Well, remember that to find out the number of valence electrons for the 8 main groups, those are the ones with the Roman numerals 1, 2, and then you skip the D block, those transition metals, and you get to 3, 4, 5, 6, 7, 8. Those are called the main group elements. And the number of valence electrons is the same as their group number, right, which is the Roman numeral on the top of the column. So a couple units ago when we drew the dot structures, right, it looked like this. We went and found the Roman numeral on the top of the column, and that told us the valence electrons, and then we put a dot to indicate how many valence electrons there were. So a Lewis structure is also synonymous with a dot diagram. And what it does is it shows the number of valence electrons. We usually call them Lewis structures, though, when we're actually talking about chemical compounds. So we're going to talk about chemical compounds and Lewis structures. But let's review again the valence electrons. How do you find out how many there are? Well, you look at the number at the top of the column. Of course, on our periodic table, those numbers are Roman numerals. But hopefully you can read some Roman numerals. All right, so let's take a look at a compound like sodium chloride. How many valence electrons would sodium chloride have? Well, we go to the column, we find sodium, right? Sodium has 1 valence electron because it's in that very first column. And then we find chlorine here in the 7th column, right? Almost the second one from the end. And that has 7 valence electrons, so 7 plus 1 is 8. 8? What's the significance of 8? Remember, all atoms want to have 8, right? That's why they bond, is to get 8. Whoa, makes sense, huh? All right, so our Lewis structure, our dot diagram, is going to show this ionic bond by showing that the electron has been transferred from the metal, the one on the left side of the periodic table, to the nonmetal, the one on the right side of the periodic table. So, for example, if we took a look at our original dot structures for sodium and chlorine, right? Sodium would have 1 valence electron, and chlorine would have 7 valence electrons. All right, so their dot structures would look like this, and we would have drawn those a couple units ago. Well, in our Lewis structure, to show the structure for sodium chloride, which has an ionic bond, right, the sodium transfers that electron to chlorine. So when we write the Lewis structure, we show that transfer. So we have sodium, which has lost its electron, right? There's no dots here, with a positive 1 charge. And our chlorine, which now has all 8 dots, all 8 electrons, with a negative 1 charge. Now, what are these brackets? Well, anytime an element has a charge, when we're writing Lewis structures, we're going to put a bracket around it, and we're going to put the magnitude of the charge on the outside of the bracket. All right, let's take a look at how we do this. It's actually really great for ionic compounds. So we're going to go through the steps, and we're going to use magnesium oxide as our example. So step 1 is just write down the elements that are in the compound. So Mg and O. Next thing we're going to do is we're going to show that the metal transfers all of its electrons to the nonmetal, right? So here would be what we'd do if we had done dots before, right? 2 for magnesium, because magnesium's in column 2. And then 6 for oxygen, because oxygen is in column 6, third from the end. Right? Magnesium is going to transfer its electrons to oxygen. So when I write the Lewis structure, all I do is I take brackets and I put them around the metal, right? The metal is going to lose all of its electrons. So no dots, just brackets, and a charge on the outside indicating how many electrons the magnesium lost. So magnesium was in column 2. It had 2 to give. So I'm going to write magnesium with brackets and a +2 to show that it lost 2 electrons. Now, my oxygen, right, took all of the electrons. So I'm going to put 8 dots around the oxygen. And then I'm going to put brackets and the charge on the outside to indicate how many electrons oxygen gained. So here are all dots, all my 8, brackets, -2. So the ionic Lewis structures are really easy because we take the metal, no dots, just brackets and charge to indicate how many it lost. So, right, remember, we even have those written on our periodic table, +1, +2, +3, right? So we write that on the outside of the bracket. We put all 8 dots around the nonmetal, like our oxygen here, and we put brackets and the charge on the oxygen. And if you look at the periodic table and you look up at the top, right, that's the -2 column. Woo, it makes sense. So that is a Lewis structure for magnesium oxide. Let's try some more. All right, what about lithium oxide? Well, lithium each has, right, it's in that very first column, so each has 1 valence electron. And here's our oxygen again with its 6. So the reason why I have 2 lithium in this compound, right, is because oxygen needs 8, so it needs 2 electrons. And so lithium is going to give them up. Now here I have multiple atoms. Right, magnesium was just 1 magnesium, 1 oxygen. So first thing I do is I write the elements, and I'm just going to put the lithiums around the oxygen. It doesn't matter if I put them like this or I put them in a straight line, as long as, you know, they're around the oxygen to show that lithium's giving its electrons to oxygen. Next step, put brackets around the lithium and a charge to indicate how many electrons it lost. So each lithium has 1 to lose, so brackets +1 for each of them. And then we put all of our electrons, all of our dots around oxygen. So you're going to put 8 dots around oxygen, put brackets, and a -2 to show that it picked up 2. Now, you don't have to make the dots different colors. It's just to show that there are my 2 electrons from lithium. So it picked up 2 electrons, and it has a charge of -2. All right, let's have you try one. Try calcium chloride. The formula for calcium chloride is CaCl2. So pause the video and see if you can draw the Lewis structure for this ionic compound. All right, well, let's see what you did. So first step, right, is you write down your elements. There's 1 calcium and 2 chlorine, and this time I put them in a straight line, but again, you can put them in an L, totally up to you, as long as they're around the calcium. Each calcium lost 2 electrons, so I'm going to put a bracket and the +2 on the outside to show that it lost 2 electrons. And then I put 8 dots around each of the chlorines, and I put brackets around it to show how many electrons each chlorine got. Each chlorine already had 7, so it can only take 1. So that's why its charge is -1. How'd you do? All right, how about this one? Do aluminum chloride. Pause the video, see if you can get it right. Well, if you did this right, aluminum, you wrote your aluminum and you put +3 because it had 3 to lose. And then you put all 8 dots around your chlorine atom, which is your nonmetal. Each chlorine had 7, so it could only pick up 1, so brackets with a -1. Now, you can write these chlorines around aluminum any way you want, as long as they're around the chlorine. How'd you do? All right, do the check your learning practice at the bottom of the page, and I'll see you in class.